Hello everyone, welcome to Chemistry with Professor John Nguyen. We are on the last part of Introduction to Chemistry, and this is biological chemistry, or also known as biochemistry. I believe on the first part of the video, on this section we got to carbohydrate, all right, and that's should be we can start right there. Pick up from last time. Okay, so we got monosaccharides or simple sugars like glucose and fructose connected together by the bond known as glycosidic linkage or glycosidic bond. Notice that the OH here is pointing down, okay, it's downward with respect to the ring, okay, structure. That is um, very important. It's known as alpha, which is the digestible form of um, carbohydrate, okay. All right, so that's the linkage, that's a connection, chemical connection between glucose and fructose to give us sucrose, which is a disaccharide. Di means two, okay. It contains two monosaccharides bonded together, okay. We're known as disaccharides. All right. Now, if we take a glucose connect to another glucose, you notice again that's pointing down, okay. That's alpha, okay. Connect to another glucose, keep connecting. We got a cell, a polysaccharide, okay. Polysaccharide. It's the polymers of monosaccharides. All right. And here's a summary of simple sugars like monosaccharides, like glucose, okay? And then we got to polysaccharides, that's the polymers or complex carbohydrate. Now, in terms of polysaccharides, we have two different kinds um, for the in plants, okay? We have starch and cellulose, both composed of polymers of glucose, and these are in plants, okay? Now, the third kind is the glycogens, and it's similar to starch, except it has branches, okay, coming off. So it's more complex, and that's a form of polysaccharide stored in animals, okay. All right. There is a difference, as I mentioned earlier, between starch and cellulose, and that's the bond, okay, and that's known as in starch, okay. You probably heard about amylose and amylopectins. They both uh, are different form of starch, okay, and they are digestible, and the difference is that's alpha linkage, that's digestible form, all right. Now, however, in cellulose, uh, the connections are different, okay, and it's point up. Now, it point up, the OH point up, we call that beta linkage. If you remember beta linkage in cellulose, that's good enough, okay, and that's the difference. And that's the indigestible form of polysaccharides, and that's in cellulose, also known as fibers. All right. Starch is a common um, form of polysaccharides for example, in potato, in grains like rice, stuff like that, corns, and it's soft, and we can digest them. We can chew them and swallow and digest them. The linkage are alpha linkage, so it's pretty easy to hydrolyze and to get us glucose. Okay, so when we eat starch, it breaks down right away and form glucose available for energy. Okay, immediately. All right. Now, on the other hand, and remember that's because it's alpha. All right. Um, now, now, in cellulose, is the connection is different. It's beta, so um, we not able to digest, and therefore it will serve as fibers. Okay, and it will right through. And when we eat cellulose, it will pass right through the intestine and undigested. It absorbs all the toxin and help us to detox. Okay, so that's nice about cellulose as polysaccharides. All right. Uh, okay, so that's will close up the first part, which is carbohydrate. Very good biomolecules. And in the next video, we'll continue with lipids. All right. Thank you, everyone, and see you guys soon in the next video.